So let's talk a little bit more about complex numbers. There is a specific way that we should write a complex number in standard form. When we write in standard form, we should have the constant term first and then the imaginary terms. So if here would be an example, 2 plus 3i. The I comes second, kind of like in standard form a quadratic. We write it like this, with the x squared term, then the x term, and then the number. So standard form for a complex number has the constant term and the I term. I would imagine when you do an assignment in Delta Math, they're going to want your answers in standard form. So we've talked before about real numbers. Real numbers would be like 5, square root 3, square root 7. But an imaginary number has an I in it. This one is actually called a pure imaginary. I would be a pure imaginary. 5i would be pure imaginary. 2i would be pure imaginary because it doesn't have a constant term with it. But this one, 5 plus 2i, would not be pure imaginary because it's got a real number with an imaginary number. So for it to be a pure imaginary, you have to just have the I without the constant term. So let's talk about adding and subtracting complex numbers. So if I had something like 2 plus 3i, and I wanted to add 5 minus 2i. We would do this just like we would with real numbers. We're going to look for like terms. So I have 2 and 5 are like terms, so that would be 7. And then I have positive 3i and negative 2i, which would make positive 1i. So adding and subtracting is basically just like how you would do if you had variables. So let's talk about multiplying. So let's multiply 2 plus 3i times 5 minus 7i. So we, again, would multiply just like I is a variable, even though we know I represents something, so we'll have to deal with that in a minute, but we're going to start off by double distributing. So 2 times 5 is 10, and 2 times negative 7i is negative 14i. 3i times 5 is plus 15i, and 3i times negative 7i is negative 21i squared. So let's go through and put our like terms together. I have 10, but I'm also going to have this one. Because if you'll go back and remember, I squared is one of our units, or a definition of one of our imaginary units. I squared can be substituted with negative 1. I squared and negative 1 are the same thing. So this is not an imaginary number anymore, because I have negative 21 times negative 1, so this becomes plus 21. So I have 10, subtract, and I'm going to go ahead and put those together. So that would be negative 14 and positive 15 would be I. And then I can put the 10 and the 21 together, so I would get 31 minus I. So this is the product of those two imaginaries. Let's do another one like that. Let's just do another example. Let's go 4 plus I and 3 minus 2i. So I'm going to multiply. I want to find the product. So I've got 4 times 3, which is 12, minus 8i, plus 3i, and this would be minus 2i squared. But I squared really means negative 1. So this negative 2 actually turns into positive 2. So then when I put my like terms together, I have 12 and positive 2, which is 14. And then negative 8i and positive 3i is negative 5i. let's think about one where you have a binomial and you're squaring it. So what if it was 2 plus 3i squared? Well, because of this plus sign, I cannot just square each term. I have to write this out twice. 2 plus 3i and 2 plus 3i. So I would get 4 plus 6i plus 6i plus 9i squared. And we know that I squared turns into -1. So what it actually does is just changes the sign of last term. So this becomes -9. And I'm adding it to +4, which becomes -5 plus 12i. I want to do one more with you. Let's do one where it's the same numbers, but different signs. So 2 plus 3i and 2 minus 3i. We've seen something like this before. We'll see if we can't go back and make a connection. But when I multiply this, I get 4 minus 6i plus 6i minus 9i squared. Well, the negative 6i and the positive 6i are going to cancel. This is going to turn into -1, so this becomes +9. So I have 4 plus 9, which is 13. This is interesting because I started multiplying two imaginary numbers, but I ended up with a real number for an answer. So I had i's in the original problem, but my product does not have an I. So think to yourself, what would make this happen? What would make the i's cancel out? So you're probably thinking, yeah, these middle terms canceled out. How come they canceled out? Because these were the opposite signs. This has a special term. These are called conjugates. So if I want to think about a conjugate to 4 plus I, the conjugate to 4 plus I would be 4 minus I. So a conjugate would make something cancel out. We've seen conjugates before, like if I had x squared minus 9, that becomes x plus 3, x minus 3. So like here, I'll let you kind of think about it. Here I had the sum of squares. Here's the difference of squares. So when you have the sum of squares, it factors back into imaginary numbers. And we'll get to that eventually.